So, last time let me just draw the 3 dimensional. We will discussing, I think we discussed all the boundary conditions on the plate, on the thick. So, it is a thick plate, we call it thick plate, no assumptions, it is a 3 dimensional plate. So, it is a thick plate. So, I will just write a simple phrase, thick plate. As opposed to thin plate, which is the subject matter of most of the books on plates and shells. There we study thin shells or thin beams. In strength of material we study thin beams, thin, slender means thin, thin beams, thick plates, I mean thin plate and thin shell also, curved, but it is thin. So, all the theory that is there in most of the books, they cover thin. Now, we are talking of thick. So, thick, let me draw the, I think a small diagram is needed. Thick plate is something like a brick, real brick in field. So, all the dimensions are more or less similar means of the same range. You cannot say that this is very small compared to the other. So, this is a thick, and then I had done that this is right handed screw system. So, this is middle plane. In shells we call it middle surface. Of course, difference between surface and plane I do not know very much. Surface, I think both mean the same thing, I believe. Plane, no, plane is says it is plane. Surface can be curved also. A surface, any surface. Surface is a 2 dimensional, a road surface or your room surface or this one. So, it is a 2 dimensional. So, plane means yes, it is, no, surface can be, yes. So, in shells we call it surface, it cannot be plane in shells, because once it is curved, so it cannot be. So, that is the difference. In beam it is beam, middle plane of beam, width B, very small width, but then it is a plane, but then we take only a line, neutral axis we call it, because width is not important in beam. Okay, so this is, so now let us, so this is x equal to 0, this one is x equal, this edge is x equal to 0, and this edge is y equal to 0. This top surface is z equal to plus h by 2, top surface, this is h by 2. Okay, so this is top surface is plus h by 2, bottom surface means this. So, what are the boundary conditions we have noted down? At x equal to 0, see similar thing will be there also at x equal to a. If you are saying, so we can have boundary condition on x equal to a, but we are talking of x equal to 0. So, x equal to 0, what are the boundary conditions? X equal to 0, it is supported on diaphragm. I told you that first we have to, then it is subjected to some loading. Some loading means it is on top surface, some variation, and everything is positive in the positive direction. So, everything is, it is given in this direction. There can also be a loading in y direction, there can also be a loading in x direction. So, let us say it is a px, py and pz. Loading on the surface, loading can be applied only on the top surface. So, px, py, pz, but then here we make distinction between bottom surface, top surface, middle surface. Middle surface we cannot apply loading, bottom surface we can apply. So, if you apply like this, so let us call it this plus, that means it is at h by 2 plus h by 2 on a positive surface plus h by 2. Okay. So, this is now boundary condition is x equal to 0. I told you x equal to 0 is this, this one, this edge, yes. What is the displacement in x direction? X direction is possible. I told you diaphragm x equal to. So, what is free corresponding to, that means u is given, u is free. So, sorry, yes, u is not 0. So, what will be 0? What is the corresponding force which can be sigma x? So, sigma x will say here on this edge, because it is a diaphragm support, there is no load, there is no normal stress there. There is no normal stress in x direction. So, the boundary condition is sigma x equal to 0, not u. U is non-zero because it is a diaphragm, and I think I have explained enough last time what is a diaphragm. Diaphragm is a rigid plane, rigid plate, and which is very flexible out of the plane. So, displacement is there in x direction. Since displacement is there, just like cantilever beam, displacement is there. So, we say shear force is 0, and the moment we support it with the roller, we say now W is 0, shear force is there. So, only one thing can be 0, not both. So, sigma x is 0. Then in y direction, in this direction, yes, V is 0, V. Then in W direction, W, what is the displacement? All the points in this plane, all the points, it is not only at one point, it is saying only at x equal to 0. So, that means we are talking of the edge plane. So, plane can be like this, plane is very wide, this is the depth of the, this is the edge. So, at every point on this plane, W is 0, transverse displacement is 0, W. So, I can write here all these quantities will be functions of, sigma is a function of what? 3 quantities. Sigma is a every quantity is a function of x, y, z, but here what is, yes, 0 comma y comma z. So, the meaning is this, V means 0 comma y comma z, W means okay. So, this is clear. Now, similarly at y equal to 0, y y equal to 0 means which edge? It is this edge, this edge. So, this edge will be again diaphragm. So, sigma y is 0, sigma y which is x 0 z is 0. What about u? Because either u is 0, because u means this u is not 0. Since u is not there, sigma x, okay, sigma sigma y, yes, no, it is not. U is 0, Achha, I should have started with u. Achha, this corresponds to v. Okay, so u, I will write it before. U is 0, u x 0 z, very good, please. And then again w, and similar boundary conditions are there also similar at also y equal to L or y equal to B. This is x equal to A, this one is A and this one is B. So, at y equal to B, similar boundary conditions, again u will be 0, but then it is 0 x B z equal to 0, then sigma y x B z 0 and then w x B z 0. Similarly, here x equal to A, because we are talking of diaphragm supported. So, sigma x A y z equal to 0. So, 4 now okay. So, now what is remaining is at z equal to minus h by 2, what is the boundary condition? These 4 are over, this is complete over. So, now we are talking of z equal to minus h by 2, h by 2. So, what is this? That is UVW all is free, it can have U, it can have V, it can have W. So, I cannot prescribe UVW. What I can prescribe is corresponding, corresponding to U will be sigma x. So, sigma x is 0, then corresponding to V on that, corresponding to U is not sigma x. Yes, what is this is where on that plane bottom and top, what are the stresses on this? This is what? This is sigma z. What is this? Tau z y and tau z x. Similarly, there also. So, what is in u direction? It is tau zx is zx and it is x y minus h by 2 0. Then second component of shear tau z y x y minus h by 2 is 0, and third one is corresponding to W, it will be, what is the stress? What is the other stress? Sigma z, on this plane these three components of stresses, then what is the boundary condition on here at z equal to plus h by 2? Again, it all depends. You can apply, see, you can apply a tangential load. Supposing this thick plate is there, it is a part of a bridge or something, some channel which is supported from ground and water is flowing. So, there will be shear, there will be water flowing, means there will be some friction force that will act as a shear force, tangential force, it will be there. So, it is possible, it is possible to apply tangential, but in this case we are not applying, we are applying only a simply supported. So, we are applying only. So, in x direction we are saying at z equal to this, what is the component? It is tau zx at xy plus h by 2 is equal to 0, tau zy xy minus h by 2, sorry, plus h by 2 is 0, and sigma z xy plus h by 2 is equal to what? Load. We have applied some load. We have applied some load. We call it Pz plus Pz xy. It is a function of xy only. Pz xy we have applied, and I am calling it just to signify that it is acting on the top surface. So, now we have, so everything is clear, all the faces boundary condition has been specified, and through boundary condition loading is also specified. Loading is a part of boundary condition in this case. It is loaded because of these three boundary conditions, top, bottom, this is the bottom. So, now this is in a state of equilibrium. So, well, you have to solve this. So, it is a simply supported, diaphragm supported, which is called simply supported thick plate. Load. How to represent the load? No. The problem is three dimensional. Is a 3D one, and did we derive the three equilibrium equations in terms of displacement? No, but it can be derived. You have the governing three dimensional problem, the governing equations are the three partial differential equations of equilibrium in terms of terms of displacement. Now, this is all right. In the moment I am writing in terms of displacement, because this is there, your equations are this, tau ij j plus bi equal to rho ui. This is equilibrium equations. In terms of stresses, substitute this or replace ij by displacements by ui. You can do that, no? Yes, it can be. It is a pure substitution. We have got 15 equations, 6 constitutive relations, stress and strain, and then 6 strain displacement relations. So, we can find out stress, substitute strain, right hand side, C matrix multiplied by strain, stress is equal to C multiplied by strain, substitute strain in terms of displacement. So, you have got now sigma in terms of 3 components of displacement. All these sigma you please substitute here. You will get a coupled differential equation, partial differential equation in 3 dimension in terms of 3 displacement. So, that is what I am writing here. The governing equations are the partial differential equations of equilibrium in terms of displacements, and number is 3 here, 3 numbers in 3 unknowns, but they are all differential equations. So, it is a 3D problem. So, our aim is how to reduce the dimension, how to the dimension of, how to reduce the dimension of the governing differential equations. Dimension means is the 3 dimension I want to reduce now, either by 1 or by 2, depending upon what we can do. Why we want to reduce the dimension? Because I cannot solve these 3 dimensional equations. It is not easy, it is just impossible to solve this differential equation. So, in that case what I do, I assume in that case, because this is my aim. So, for this I assume that my loading which I have written here is pz na pz plus and it is a function of xy. It is a function of xy. So, we assume that this, let us express this in terms of Fourier series. You see, Fourier has any function can be represented in terms of sine and cosine, in terms of trigonometric function, any general function. This is my general function pxy, some loading, some variation is given. I want to express this in terms of Fourier series. Fourier series means number of orthogonal. So, I will just have this. This is a 2 dimension. So, first of all, there has to be 2 m. There are 2 modes going from n, again going from, and here it is infinity, but then infinity is never implied, it is always finite, equal to n. This is made equal to n. N can be as large as possible. Then this P, it can be represented as P. I will write here just I will forget about Z, because I am assuming that let it be Z, so that you know it is the transverse displacement, and it is Mn, Pmn, some coefficient without any, it is independent of x and y, multiplied by sine m pi x by a into sine n pi y by b. This is possible for any function. This is a general method, how to express any general function in terms of this. Only thing, you have to take infinite number of terms, then only it is true. Normally, it is not possible to go for infinite, and that is why we have approximation. So, this introduces, so it is true, because since infinity cannot be taken, since infinity is not possible, we take only a finite means measurable, finite number of terms in this series, this infinite series, this is infinite series, in this infinite series. So, this will never be exact, you will always have a approximation. So, if you write this, so I just want to very clearly say this, so that you do not make mistake later on, that so then this will be approximate equal to So, of course, this introduces some error. So, there is nothing like exact. So, in real world, in reality, in practice, somebody says I have got exact solution. So, nothing is exact, it will all depend upon how good is your. Now, once you have this one, in that case, and so this is loading is all right. Now, last time I have already told you that is how to what kind of these boundary conditions that which we have prescribed in terms of sine cosine, we have expressed this, is it not? We have already expressed how this can be written in terms of sine and cosine, all these 4 boundary conditions. Yes, for example, x equal to 0, x equal to 0, we have said that what is x equal to 0? Sigma x is sigma x in anyway 0. I do not want to repeat everything. V is 0, but what is V? I mean V is 0, that is okay, but then how to write down this such that V which is 0 y z, how it can be written? It can be written as I think we have done it. We in terms of mn, didn't I give this last time? So what was the meaning of that? See, that is also, see here mn is there, so I did not, so it is the meaning is same. This is summation over m and n of going up to n. So it is V capital, some I think capital we have taken na, mn, and then for this here it is this one is V is what is the condition? X equal to 0. So what is the condition? That so x equal to V, no. See, we are talking of x equal to 0, no? So we are talking of this edge, here. So that one, it should have what kind of variation? What is this quantity? This quantity is V quantity is this. V is going in along in the diaphragm itself. V is displacement in the diaphragm itself. So what is the variation we have given? Just see what is the variation we have given. It must have given sine cosine. It must be sine m pi x by a into cosine n pi y by b. So this is this, and this I have already explained why we have taken. I think W is easier to explain, and this one is also very easy to explain, that out of in case how to put so just a minute. So there is a this is a function of z, Vm. So it is a product of x, y and z. Now this is unknown. This I have kept unknown function. I do not know this. So I have kept one unknown and two known. Two known based upon the behavior, the kind of boundary condition. So this can be written, but then this can be written provided we have made this loading which I showed you just now, this one, this, like this. Loading also is important, So loading is important, then we can write down this, and then W will be, because this is, unless we do it number of times, we will not be, this will be it is W mn z, and it is W displacement sine in both direction, sine m pi x U also we had given, I think, for this edge. U also we had given, although it is this is okay, this sigma x is okay, this constitutes the boundary condition, but what is the U variation? what is the u variation in the plate, in which direction, in x equal to 0. So, if it is this is x equal to 0, so x equal to this. So, we had planned, how does u vary, between these two support, x equal to 0 and x equal to a, how does it vary, is it not? So, that one we had argued, yes, this one will be, u will be again see, otherwise if you do not understand this here, between u, which is a normal displacement to the diaphragm, the first function is cosine, because the edges can move like this. So, we are taking cosine here, some in the center 0, and here it will be negative. Cosine is always goes like this, up and down. So, center 0. So, this is first we take cosine, while for v, see, for v it is sine, because along the edge x equal to 0, if you see on that edge, it will be varying sign, because maximum will be occurring in the center. So, it will be sine. So, these things are very important. So, please understand this very carefully. So, now we have written down this, we can solve the problem, but then I will go slowly. You can see this. I have taken here in one dimension, because let us start from one direction only in x, no variation in y, then we will go to two dimension. So, I have taken a loading which says Px varies as some P naught. What is the meaning of this? P naught is the amplitude sin pi x by a. So, its variation is something like this, and maximum in the center is P naught. You see, x equal to 0 0, x equal to a, again sin pi will be 0, and at x equal to pi by 2 means 1. So, 1, and so therefore, P naught. So, this maximum value is P naught here in the center. In the center it is P naught, and that is shown. That is called amplitude. Amplitude of the, actually it is used in vibrations. When the beam vibrates, so it is the first mode of vibration, and this is the amplitude of vibration, and this is the first mode. So, the same concept is used for solving static problem. Only thing, in static we cannot take all the modes. All the modes of vibrations cannot be taken for static problem. It can be only first, third, fifth, seventh, etc. Odd modes only will contribute to statics, while in dynamics you can take all. When we are dealing with dynamics, m and n will vary, because dynamics means it can vibrate in both. So, okay. So, then this is equal to, now let us say I have a simple load. So, this is called sinusoidal load. My load is sinusoidal here, but that represent Px sinusoidal. Now, in reality, let us say my load is constant P naught. So, I have got P naught. So, this one is P naught, means this is UDL, it is not sinusoidal, this load is UDL. Now, how can I represent UDL? How will I be able to represent a simple UDL? How to represent this UDL? UDL is P naught constant, one value P naught constant value So, I can express, I told you this is where that this function constant can be represented as some p1 sin pi x by a, that means this is p1, this, it is like this is the first mode, this is the first mode p1 is the mode of vibration, first mode of vibration sin, it is, so I have written here p naught equal to p1 sin pi x by a, is it okay, plus some p3, now I have missed p2, P3 vibration mode will be like this, and all these are having equal amplitudes, 1/3, 3, and then this one the amplitude of vibration is P3. So, this will be P3 sin 3 pi x by a, m or n whatever you want to say, this is in one dimension. So, here it is only sin, I mean sorry 3, the third one m pi x. So, 3 pi x by a, is it okay, this is a is total, plus P5 sin 5 pi x by P5, how will it look, it is like this, between this length, total length, see there are 5 parts, and then this mode will be like this, it so happens that this is I mean if this is positive, yes, fifth one will be positive, third one this, but this will become negative. So, here this central becomes positive, like this you can go up to Pm sin m pi x by a, where m is tending to infinity. If you want to represent this, this is also used. Sometimes you want to have m going from 1, 2, 3, 4 only, when you write computer program, because here I will have to give m going from 1, 3, 5, 7, how will I give it? Normally when you say do 1 to 100, it will take all 1, 2, 3, 4, 5, 6, 7, 8. So, now I will define one different m dash, some m dash I will define, m dash such a way that 2m minus 1 pi x by a, because when m equal to 1, this is 1, when m equal to 2, this is 4 minus 1, 3, when m equal to 3, 6 minus 1, 5. So, automatically you will get all the terms. So, only thing is, and you write this sin m dash pi x by a. So, you just you give m dash is going from 1, 2, 3, 4, so that you do not have to worry about only odd numbers. This is in program, because every program you will have to program. See all these, although this is an analytical solution method, it will require lot of computation, and you will have to program it. Program it means for computer, then only. By the way, this method is was given by a French scientist whose name he presented this to French Academy. This was his presented, I know somewhere it is given dates, some 1800 something he presented this to French Academy of Sciences, how to solve a complex 2 and 3 dimensional problem, and his name happened to be Navier, 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 he is a Frenchman. So, French are good in mathematics. Russians, Soviet Union people, old Soviet bloc, they were good, not now. Now it has become very weak after breakage of whole Soviet Union. So, old was extremely good, 1700, 1800 was extremely good. So, French they are good in mathematics. So, they can visualize, because this is solution of partial differential equation, how to solve 3-dimensional PDE, but with physics, not only as mathematician. So, he gave Navier, so he is a Frenchman. So, it is called Navier solution. It is called Navier solution. So, now I have expressed this. I am now, so a general term P naught can be written as Pm sin m pi x by E. The general term of this series is m going from 1 to, I mean 1 to anything, and only odd terms here. So, then this is okay, and then now the problem is how to evaluate. See, left hand side is my own number. Yes, I have got a UDL of 10 newtons per meter square, or per centimeter square something. So, I have got a force that is prescribed. Now, I want to represent that as a combination of sine functions. So, is it possible? Yes, it is possible by this. So, how to evaluate Pm, that coefficient, and once you know Pm means you just change the. So, anyway, P0 equal to, in general, P0 is equal to this, multiply both sides by sine another n pi x by a, same n. So, this is sine m pi x by a, here now we are multiplying by n pi x by a and integrate between the limits 0 to a. So, I have multiplied both sides by sine n pi x by a dx. Left hand side P naught was there. So, sine this multiplication, integrate from 0 to a, left hand side, right hand side it is summation is okay, then Pm sine m pi x by a was already there. So, you have to multiply by sine this dx integral, integrate both sides by multiplication of this. So, this one has been multiplied, this has been multiplied, and then we are integrating both sides. This right hand side, any function, if you integrate, try to integrate product of two sine or cosine like this m and n, you will find that for m equal to n, I have got its value, and m equal to n, right hand side will be equal to a by 2. Okay, a by 2. This sine square हो जाएगा, m equal to n, multiply this by sine square, then reduce this to 1 minus 1 half 1 minus cosine of 2 angle, twice the angle of this, and then integrate between 0 and you will get a by 2. So, this integral will become right hand side. If m is not equal to n, the right hand side is equal to 0. So, now we are talking of only, it has got values non-zero only for m equal to n. So, for m equal to n, now left hand side is P naught, integral of sine equal to minus cosine, and since it is there multiply, this one is there. So, it will be x n pi a by m pi 0 to equal to summation P m a by 2. Am I doing any mistake? So, minus Now, this is A, P naught A will come, and then this one, what is the value of cosine m pi x by A 0 2? It can be written like this, it will be minus, this is okay. When it is 0, cos 0 equal to 1. So, this is cos 0 equal to 1, cos, when cos equal to A, I mean sorry, this x equal to A means m pi is minus 1 to the power m. So, this is m to, minus 1 to the power m minus 1 p naught by m pi equal to this. Now, that one becomes left hand side is what? Because otherwise it is 0 na. If m equal to, if for m equal to odd, minus 2, but plus, where is the negative sign? No, minus plus, minus plus, okay. So, for m equal to odd, if it is even means 2 means this will become 1 and this minus 1. So, this will be 0. For all even m, this is equal to 0. So, for odd values of m, for odd, so this is for odd values, for this is okay, and therefore, P m you get equal to 4 P naught by m pi, and therefore, I can write P m. So, from here, yes, this is very important. See, I find it very important this to understand, and that is why, because I did not understand when I was a student. How does we are writing that this UDL I am representing in terms of this sign, this sign, this sign, how they are equal? You have to explain. Now, you can see here. So, this is okay, P m, this one, previous slide क्या हो गया? So, read from any book some introductory part of Fourier series, Fourier, Fourier series. Fourier again is name. So, Fourier series, how to represent any function in terms of trigonometric functions. So, because that is very useful in solving partial differential equation. That is the starting point for solution of partial differential equation. Any book on PDE, you have to study that. So, our problem is physical problem. So, then next one I have just written here, P1. P1 will be what? P naught by just pi, 4 P naught by pi. So, I have taken P naught by pi. So, this is P1, this is my P1. P3 is 4 P naught by 3 pi, P3 is this, P5 is 4 P naught by 5 pi, it is like this is P5 like this. Now, you see what happens, this cannot represent my, I am see, I am seeing, I am adding this. Now, this one is sine, I want a UDL, I want a UDL load. So, my first term is giving me a sine, second term what do? It will because this is negative, this is plus and this is negative, this is plus, this one is plus, top is plus. So, the middle portion 1/3 here, this portion will be brought down. If you add this plus this, so this will come down, and this here from this third it will just go up. So, some flattening will take place. Idea is that some flattening will take place. Is it okay? Instead of sine curve, it will become something like this. If you add this plus this, so it might become something like this red line. Now, I am again coming here, third P3. This one is bringing up again the central, slight increase, whatever we got, this will go up, but only in the 1/5 position, only in the 1/5 region, and that too maximum in the center. So, slightly it will go up, and here again, but this in 1/5 region, again this is going up only. So, if you add this plus this, then this in the 1/5 region, this will go up, this again will go up, it is going up, and then next one it is coming down because of this, whatever we had got it here, this plus this, if you add this third term, so this brings down. So, whatever was there, so that means this goes up and this comes down. So, more flattening. What I am saying is this, your slope goes on increasing. If you have a slope here, it goes on increasing as the number of terms are, and finally, when enough numbers are added, your curve looks like this. Finally, this central more 99% or 95%, not 99%, 95% of this length will have a constant value, because later on the change will be very little. All these values, as this will go on increasing now m. So, here the change will be very little. So, almost convergence. So, this will remain flat, and this will start coming closer to, becoming vertical here. It cannot become exactly vertical. You want this, but that is not possible. So, a UDL, this one, this UDL is represented, if you add such terms, such Fourier series, these are called Fourier series, and which are coefficients, all these Fourier coefficients. For each term has got P1, P2, P3, they are all amplitude, we call it also amplitudes, they can be all Fourier coefficients also. So, the UDL can be represented like this, which is similar to UDL, and it helps because sine cosine functions are easier to integrate, deal with. Differentiation, what is another advantage of sine cosine function? Orthogonality. Orthogonality means if you multiply sine cosine, then you will m equal to n, there is non-zero, and m not equal to n there will be. So, that is called orthogonality condition. Anything else? One more property, sine cosine, it has got infinite derivatives. So, there is no limit on derivatives, infinite derivatives. A linear function a plus bx will have only one derivative. So, if you are representing by a linear function your complex variation, so it is very approximate. This is no such limit. So, we say with orthogonal function, you get what is called complete solution. It helps you to obtain solution, but then you get a complete solution because you do not have any limit on the derivatives. Okay, so, this is in one dimension. Same thing can be done in two dimension also. Instead of writing just, if you have a function p x y, UDL constant in x and y. So, I will be writing coefficient Pmn, Mn both, and instead of just one sign term, I will have one more sign n, m and n, and both will be, so it will be product of such functions in both dimension, in x dimension and y dimension. So, that can be okay. So, that is what is in 2 dimension. This is diaphragm. So, I have something like this. This has to be small. So, this is what P11, m equal to 1, n equal to 1. I can express the same thing in, so I can write it now Pmn in 2 dimension. Pm, instead of writing just Pm, multiplied by sine and this summation over both m and n can represent a constant function P naught. P naught, supposing there is UDL, so this is P naught is UDL like this. This can be so there it will become. So, you multiply. So, what you will do? You will multiply. How will you get the coefficient Pmn? We want to find out Pmn. Pmn to be found out. This representation is there. UDL is expressed as this. Now, how many terms? Yes, Pmn has to be found out. So, multiply both sides P naught into sine m pi x by a, again sine n pi y by a b, and then integrate x going from 0 to a, y going from 0 to b. Is it okay, Vishnu Priya? So, this is equal to left hand side multiply right hand side. You see, we have multiplied by this. So, this will become square dx into again sin square n pi y by b dy. So, here of course integral means dx dy, double integral, and if you do this you will get, what will you get, Mn, it will be similar. What will you get, please tell me. If you do this whole operation, see here in one dimension we got this, now see this can be integrated, here again integration by parts, 2 separately, product of 2, you can do it separately. So, you will get P Mn equal to what, 16 pi, 16 P naught. Yes, 4 you got here, in one dimension you got 4 coefficient, you will get 4 more. So, 16, 4 into 4, 16 P naught divided by M n pi. Pi square, yes, pi, you are right, pi square, double, m pi n pi will come. So, m n pi square. You can do it, do this integral, you will get it, and therefore, so now you are representing a UDL. And therefore, P naught can be written as summation (16 P naught by Mn pi square into sin So, we will have this as the, so now you know every term of this series is known in terms of P naught. Now, we do this problem has been done, we have also solved, others also have solved. See, it so happened that this problem had remained unsolved even in this form, the way I am explaining, that means reducing to one dimension and then trying to solve, getting some kind of ordinary differential equation and then dealing that ordinary differential equation to get solution as a function of z in thickness, because now we have got, once this we get rid of x and y by this process. So, we are left only with one z function of, that means we will be dealing only with this. What are those? Capital U, capital V and capital W. Oh, those are the, yes, those are the these are the, it will be in terms of this only. All this will disappear, because this will become, it will disappear because of integral that will be performing in x direction and y direction. We integrate the entire equation if any equation is given in x and y, we can also integrate that equation in both the dimension. So, nothing changes. So, once you integrate it, so you will be left only with this, which is a function of z. It is not that you have got the solution, but yes, we have got it in. Now, it is ordinary differential equation. So, this is the real approach for solving any general problem. Reduce the dimension by some assumption which is reasonable. Now, this assumption is not very bad, whatever we have done the assumption. So, now this problem, because see in the 1800, after middle of 1800, about 1800 and 1900, for 100 years nobody tried to solve this problem. Because people got fascinated with thin plate and thin shell. So, they developed the theory for thin shell and thin plate, and they say they were happy. Okay, they could, because they are physically, instead of going this way, the shell theory itself is one dimension less, plate theory itself is one dimension less. So, it was only two dimensional, and then it was somehow solved depending upon. So, real 3D problem was not solved for 100 years. After plate theory was developed in 1800, Poisson-Kirchhoff did in 1850 or I am forgetting the date, around something 1800 something, and then everybody was busy with thin only, not solving thick problem. Then came, I mean, the history, see, somebody writes this, how difficult problem, this difficult problem was not tackled until middle of last century, that means 20th century. This is 21st, so 20th century. Yes, middle of last century. For 100 years it was not tackled, and then this computers came in the because people started solving large number, I mean large system of problem, I mean complicated problem, because number of equations, algebraic equations that you could solve using computers, became easier. Earlier with hand we could solve only simple 3 by 3 equations in 3 unknowns, not more than that. But now with computers people wrote some good program of Ax equal to b, A going from anything 100 by 100, but beginning it was only simple, it was not 1000, people could not solve 1000. So, programs started being written for solving using Gaussian elimination. So, then came finite elements, 1960 came finite element method. So, finite element become very popular, and with finite element it is a numerical method, it is a discrete numerical method, it is a approximate method right from beginning. So, people could get approximate solution of any problem, including thick plates, thick shells, solid, brick, anything, because it is just discretizing in number of elements, any body, and then assembling them, and wherever they had the assembly point, means nodes were very important, are very important in finite, only through nodes connections are made in finite element. So, if you can always fill any solid with brick elements, and then you can solve in terms of the nodal values. So, even thick could be solved using finite element in 1960-65. Of course, 1960 it could not be solved thick. People first started plates and shells only, plane stress problem, then plates, then shells, thin plates, thin shells. So, 60, around the same time, now people got solution for using finite element for a thick plate, but then there was nothing to compare. How to compare that this approximate solution obtained by finite element is right? That is not there, and because finite element is an approximate method, it can be made as close to the real problem by taking very fine number of elements. So, that also became too much. So, people wanted to know, is there any problem where for which solution is available in analytical form without using any numerical method. Of course, here also approximation is there, but it is not too much approximation. So, it was only in 1969-70 that first solution came of 3-dimensional problem, and the first person who solved this, I think just I will give you the history, is these two papers appeared, this, and it happened from India. So, you should take pride in fact that yes, Indians also were there who solved this problem first. Srinivas and Rao. Srinivas was a PhD student at ISC Bangalore, he was his supervisor. So, they published a paper in 1970, International Journal of Solids and Structures, volume 6, it is about 18 pages, it is a long page, how to solve a 3-dimensional plate. Of course, they took little complex problem of orthotropic plate, things like that, but approach was developed how to attack this. And then around the same time in USA, this man Pagano, 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 very famous man, because of this paper only he became very famous. Somehow, because he published in USA and he was from USA, so all Europeans and Americans will refer his paper, not Srinivas, Srinivas and Rao paper, because they are from India, This is also there, apartheid is there, People know that yes, it has been solved by so and so in India, but American will not refer it. It is there everywhere, not giving credit to, people should give credit to, so I give credit to both. Okay. So, whenever I present, I said, you see, both of them simultaneously without knowing each other's work, and the approach that they have followed are slightly different. It is not exactly. So, those were the days which were no internet, no telephone, no connection, no Xerox machine, nothing was there. So, they were all independently done, and so this is, these two persons are responsible for solving. Now, so I always give that you must study, because it is very difficult to teach that method. The basis of the method that I have already covered, basis is the same whatever I have covered, how they will reduce the problem to one dimension, that much is done. Once you have the boundary condition, once you have the loading approximated as a function of two trigonometric function, both of them have done the same thing, but the approach for solving this through thickness is different. So, I would urge you, please take these papers. I will request you if you can make it available, both these papers. Yashaswini will make it available. So, it will be sent to you, but you have to submit it, because you will not read it, you will not do it unless. So, you rework Whatever they have done, try to simplify only for, they have done it for a complicated material. Don't worry, you take the material properties, isotropic material properties, and you simplify. I also say that you simplify the load also. I don't want that you sum, I don't want that you do it for, see, this summation has to be done till convergence reaches. See, we have to make it equal to UDL. So, first term, first plus third, first, third, fifth, then first 3, 5, 7, go on adding like this till you find that there is no change in the solution that you are finding. That process is called convergence. That means, yes, I am able to get converged solution for m equal to and n equal to 5. Let us say displacements, one can get convergence by taking about 5 terms, but stresses you will need at least about 25 to 60 terms to get its convergence. They take longer time to converge. So, you can do this later, but for the assignment you can do it. Okay, so then I am saying that let the plate be there, top surface of the plate, I am drawing only top surface. This is a top surface P Z. Yes. So, here I am taking, let me take only one so P at any point P x y plus of course Z is given by P naught. I am giving you how does the load on the top surface, it is diaphragm supported, everything is so loading is like this everywhere. Yes, it is a shell form, in the form of shell, loading surface will be a shell, is this sign. Then, so for a diaphragm supported or for a simply supported thick plate with above loading, above, this loading is, by the way, is called sinusoidal loading. The loading is sinusoidal load. With above sinusoidal load, obtain only one term, only with this load. I am not saying UDL or any other load. The plate itself is subjected only to sinusoidal load, and which is given by this. Is it okay? No summation, there is no summation here, only one term. So, obtain analytical solution via 1 Pagano's method, Arsenivas and 2 by Pagano. Pagano. This is due, will be due